Hello everyone, I am Mrs. K. I teach biology and pre-AP biology at Heron High School. If my voice is not familiar to you, that means you have Dr. Cruz as your teacher or Mr. K as your teacher. This Ed puzzle is going to go over some very important information for what we are going to be doing next time we see you, so please follow along. All right, so we're going to be learning about tree identification today and how to go about our world and figure out what trees are actually what species. All right, so trees come in many shapes and sizes. Their leaves also differ in size and shape. So some trees are round in shape or spreading in shape. Some are weeping, right? And then their leaves get even more complicated. Some of them are entire or lobed or compound. And we're going to talk about all these different things. That way you can ID your own trees within your neighborhood or where you live. All right, so again, there's many trees out there, but how do you even start to tell them apart? You might recognize this top left image as leaves from oak trees. You might recognize the leaves in the bottom left image as leaves from maple trees. But how do you start, telling apart the various types of oaks or what specific type of maple they are? And today we're going to show you the key basic features in identifying trees and how to, start using a dichotomous tree, as well as some very common tree species that you'll find in your neighborhoods and your parks, out your window. All right, so step one on figuring out what that tree is outside. You want to look at the branching type of the tree. See if it is opposite or alternate branching. So what I want you to do is look at the tree and see how its branches branch off. Try avoid looking at the trunk and look at the tinier branches. On those smaller branches, the tree for the most part is going to either have an opposite or alternate branching pattern. So what does opposite mean? Opposite means it branches off at the same points, opposite of each other. So if you look here, you could see that this opposite branching example has these areas along its stem where the twigs branch off at the same place, making these nice V patterns. They branch off opposite of each other at the same point along the branch. Then we've got alternate. Alternate branches stagger or alternate back and forth at different intervals off of branches of the tree. So we've got our main stem going here, and then we've got twigs branching off in an alternate pattern, not opposite of each other or directly opposite of each other. Therefore, it's alternate. All right, so now I'm going to ask you guys on your Ed puzzle to figure out what is the branching type of this tree here. All right, so keep in mind that nature is messy when you're actually looking at your tree. So sometimes twigs break off and make opposite branches look alternate. So look at many branches when you're actually looking at your tree. But for this simplified little tree drawing, it should be pretty easy to determine if it's opposite or alternate. All right, so why don't we get a little bit more practice with determining if something is opposite or alternate? So I want you to take a moment on your Ed puzzle to figure out if this branch or this tree branching is opposite or alternate. All right, hopefully you guys guessed opposite, so I'm going to show you an image to show why it is opposite. So on this image, I've drawn lots of little V's on here to show that the stems or the twigs are branching off in an opposite pattern at the same points opposite of each other. All right, let's try one more. So here is another branching pattern of a tree. I'd like you to look at the majority of the branches. Figure out if this is opposite or alternate. All right, hopefully you guys have been able to determine that this is an alternate branching pattern. So I've gone ahead and drawn some red lines to depict that these branches, these little twigs, for the most part, are branching off alternate in a staggered rate from each other. So they're not really branching off opposite of each other, but they kind of go up the twig, branch off to the right, go up the twig, branch off to the left, go up to the twig, branch off to the right. Pretty simple. So step two of determining what your tree is looking at the leaf. So once you've determined if it's opposite or alternate, there's only a certain set of trees that fall within that opposite category. There's a certain set of trees that fall within that alternate category. So how you hone that down past then is looking at the leaf shape. So you want to ask yourself, is it simple? Is it palmately compound or pinnately compound? So what do those things mean? Simple means it just looks like your most basic version of a leaf. You know, it's just this oval teardrop type shape. Palmately compound means that there are leaflets. So this entire thing is a leaf, but there are leaflets coming from a centralized area, kind of like fingers on a palm, which is why these are called palmately compound, because they're coming from a centralized place, just like fingers on a palm. Then we have pinnately compound. Sometimes it's just called compound. And again, this whole thing here is one leaf, but it's got many little leaflets coming off of it. So these little guys are called leaflets, but this whole thing as a whole is a leaf. Then we have bipinnately compound, which is like also called doubly compound. So you're seeing a whole leaf right here, but then it's got like, you know, littler, more complicated guys on it. All right, so beyond knowing what the general leaf shape is, what are the leaf margins? And what does leaf margin means? It means what's the texture along the side of the leaf. If the leaf is entire, like this, it means it's nice and smooth, right? If the leaf is serrate or toothed, you'll see little teeth along the side of the leaf, just single little teeth like this. Okay, if it's doubly toothed or double dentate, well, that means that there's like a spike, but it's a double spike. Little spike, big spike, little spike, big spike. All right, so that's a little bit different than just evenly spaced teeth like down here. All right, if we say that the margin is lobed, that means that there are these little lobes on the leaf. Instead of teeth, there are these big like finger-like lobes. All right, and within the leaf itself, there are several vocab terms that I would like you to familiarize yourself with. Again, margin is basically talking about, is it smooth and entire, or does it have teeth on it? The lobe is the part of the leaf that sticks out, and the sinus is like the part of the leaf that is removed, right? So the sinus is the part of the leaf that has like a deep gouge in it. All right, so we've made it past step 1, figuring out if it's opposite or alternate branching. We've got a decent look at the leaves and what the shape is and what the teething pattern is, or if they're smooth or entire or palmate. Step 3 is typically looking at the bark most of the time. So some people are capable of identifying trees when there's no leaves on them at all. So the bark can be a good indication of what the trees are. Does it have a smooth bark like a beech tree, or horizontal lenticels like cherry tree? Does it have vertical cracks like a lot of, maples or oaks? Or does it have, curved ridges like sycamore trees? So all these 3 steps are really big components to figuring out what your trees are that you're looking at. So a lot of arborists or people who are wanting to identify tree or plant species use something that's called a dichotomous key. A dichotomous key is kind of like one of those choose your own ending style books where if you would like to do this, go to this page. If you would like to do that, go to that page, right? So dichotomous trees are kind of like that in a certain way. So why don't we kind of look through what a dichotomous key generally looks like, and this is actually the one that you guys will be given to reference for. All right, so the first step that you're going to do is step 1. You're going to determine if the leaves are needle-like. If you say yes, the leaves are needle-like, then you're going to go to section 2 because it's a conifer, one of those trees that don't lose its leaves in winter. If the leaves are not needle-like, you're going to say no, and you're going to go to the deciduous tree section, section 3. All right, so let's say we're looking at a tree and it does have needles on it. All right, so then we're going to go to section 2 like it tells us to do. Then it's going to ask us 2 questions, question A and question B. Depending on if it's a yes or no, we either stay in question A or we look at question B. So the first question, this one here, are the leaves arranged in clusters of 2 to 5? Let's say the tree that we're looking at does have clusters of needles in 2 to 5. So we're going to stay in this question chain. So if yes, which yes it does, then we know that it's a type of pine tree. But what specific type of pine tree? So we're going to see these next questions. Are the needles in clusters of 5? So I'm going to look at my tree. I'm going to pull off the cluster. And I'm going to realize, no, there are not 5 clusters there. So this isn't the question that I'm looking for, and this isn't the answer that I'm looking for. So then I'm going to go to number 2. Are these needles in clusters of 2? I'm going to look at my sample. I'm going to say, yes, it does have 2 clusters. Great, we know we're in the right spot. All right, so then we're going to further go into deeper questions. Are these needles mostly 3/4 to 1.5 inches long and a yellow-green color? Or are these needles 1.5 to 4 inches long with a blue-green color and twisted? So I'm going to look at mine and I'm going to determine they're about 3 inches long and they are a blue-green color. So then I'm going to know that this is not my answer. And instead, I'm going to know that this is my answer and that my tree that I'm looking at is a Scots pine tree. All right, great. So we just worked through a theoretical example of how to go through a dichotomous tree, just answering yes and no questions and following along depending on if I am meeting what that question is asking for or not. All right, let's do one more dichotomous key sample. So I tore off a chunk of the branch right here. Okay, so we have our sample of what our tree is. We're going to start off with question 1. Are the trees needle-like, or are the leaves needle-like? So look at our leaves right here. Are they needle-like? Yes, go to section 2. No, go to deciduous tree, section 3. I would say that these are not needle-like. These look like normal leaves, okay? So then we go to section 3. This described as leaves shed every winter, and therefore they are not needle-like. Okay, good, we belong here. Okay, so then the first question it's going to ask is it opposite branching? And B all the way down here would ask, is it alternate branching? But this one here is asking, is it opposite branching? So I'm going to look at our twig that we broke off, and I could see that the branches and the leaves are coming off completely opposite of each other at the same locations. So yes, we are in section A of part 3 as opposite branching. So the first question in section A is, do the leaves have 3 to 5 lobes in a palmate, like fingers on hand arrangement? So let's look at our leaves. All right, so here's the palm, and they kind of go up in 3 general lobes. You could see that lobe 1, lobe 2, lobe 3. So yeah, we fit in this category. Do the leaves have 3 to 5 lobes? Yes, they do. All right, so let's continue down. What are the next questions that we have to yes or no to? Do the leaves have toothed edges with a V-shaped sinus? Or do the leaves not have teeth along its margin, and does it have a U-shaped sinus? So let's look at ours. So it's definitely got teeth along its edges. And if you look at the sinus, it's definitely V-shaped. This is a very distinct V-shaped sinus. So I would say we fall within category 1 and not category 2. All right, does the leaf have a deep sinus and 5 lobes? Or does the leaf have 3 lobes and not a deep sinus? So looking at this, we already counted earlier, it's got 3 lobes, and you can see that the sinus isn't very deep. All right, so I would say that A is definitely not our leaf, and B better fits it because it has 3 lobes and not a deep sinus. Therefore, the tree that we're looking at and the sample of leaves that we're looking at is a red maple, okay? If it was a silver maple, it would look like this guy with very deep lobes and 5 lobes. There we go. All right, so the following slides will go over some common tree species you'll see in the Indianapolis area. This list by no means includes all of the trees you may find, just some pretty common ones, native ones mostly. There are hundreds of tree species and thousands of tree varieties. People have been breeding many varieties of hybrids of trees for a long time to have specific fall coloration or flower colors, etc. So there's many of them, but we'll go over some simple ones. All right, so this is not directly using a dichotomous key, but I just want you to know that if your branching's opposite, then you're looking at a very small number of options of what you can have. The first one being maples, right? Maples come in typically 3 to 4 varieties. These are the 3 varieties that are most common. We've got our silver maple, which is toothed. It's got 5 lobes. It's got really deep sinuses. So again, the lobes are toothed, very deep sinuses, just like it's shown right here. And then if you were to turn that leaf over, it would kind of have a silver sheen to it, which is why it's called the silver maple. It's pretty cool. And then we've got the red maple. This is one of the ones that we did use the dichotomous key through. It's got teeth along its margins. It generally has 3 big lobes, all right, and its sinus is V-shaped, okay, very V-shaped in its sinus, okay. Then the third maple that you'll typically see is sugar maple. If you're looking at a leaf and it's reminding you of Canada, and Canada has maple syrup, and maple syrup is sugary, well then congratulations, you have a sugar maple. Its margin is not toothed. Okay, so see here, it's smooth. It's got these tips, but they're not exactly toothed. It's generally got about 5 major lobes, just like that Canada shape. And then typically if you're looking at the sinus of the leaf, it's got a U-shaped sinus, not a V-shaped sinus like the red maple. So that's how you tell those 3 trees apart. Another opposite tree is ash trees. And again, this is technically one leaf with many leaflets along the leaf stem, okay? And so ash leaves are typically, within a foot long. So the whole length of this leaf is about a foot long, and they typically contain 7 to 9 leaflets per leaf. Another opposite branching tree that you could find here in Indiana is something called dogwood trees. All right, so dogwoods have very clearly opposite branching. They have these really pretty big white or pink flowers in the spring, and then these leaves are very individual, and they've got parallel running veins. So they don't have like branching veins, they've got parallel running veins. All right, and the last very common opposite branching tree that you'll find here in Indiana is the buckeye tree. So this leaf is one entire leaf. It's not entire, but is a leaf. It's just got several leaflets coming from a palmate area. So this is a palmately compound leaf with 5 leaflets, all right? And their seeds resemble a deer eye, which is why they're called the buckeye, because their seeds kind of look like a nasty deer eye taken out of a carcass. Anyways. All right, so if you're looking at a tree that has alternate branching, this isn't quite as small of a list as opposite branching, but we'll go through some of these pretty quickly. One common alternate branching tree is a walnut tree. This is a really long leaf. Like this entire leaf is like 1 to 2 feet long. All right, and again, this is one of those compound leaves where it's got many, many leaflets. Walnut trees will have 10 plus leaflets per leaf. The walnut trees will have a dark chocolatey brown color to their bark, and right around this time of year, they've got their, green walnut pods that are getting ready to fall all over the streets and sidewalks. Then another kind of alternate branching tree is oak trees. There are many different kinds of oak trees, but they typically have these lobed patterns. They're typically accompanied by acorns, depending on if they're seeding or not this year. And the dichotomous tree or key would lead you to more distinct which specific oaks, white oaks, black oaks, pin oaks, all right? When you're describing oak leaves, the lobes are either rounded with no bristles, or the lobes are pointed, and sometimes they'll have these little bristles hanging off. So that's what that terminology is called when you're going through the dichotomous tree. All right, then we have sweet gum tree. This one's very beautiful. In the fall, it's got all sorts of colors, purples, reds, orange, yellows, like all of the pretty colors. And they're very distinct because they have this nice star-shaped pattern to their leaves. They've got really tiny teeth along their leaves, but then they've also got these spiky cherries that make it kind of painful to walk through your yard. All right, another tree, this is the state tree of Indiana, the tulip tree. So if you would tell a 3-year-old to draw a tulip flower, it might look something kind of like this. It's got, something generally like this shape. It's a very unique shape. It's very symmetrical of each other across that mid vein. So if you see something like this, it's a tulip tree. Then more alternate branching. So if you see very smooth bark like this here and very like gently toothed, smooth looking leaves, it's likely a beech tree. Then we've got sycamore trees. These leaves are huge. Look at this man's foot. The leaf is like over 10 inches wide. All right, so they've got very big leaves, and if you're looking at the branching of the tree, you might notice that the tree looks quote unquote sick. It looks like the bark's falling off of it, and the white bone is what's left. These also have cherry pod type seeds, but they're not as spiky, and if you rip them apart, it's like a nice cotton substance that flies everywhere. Then we've got the ginkgo tree. We've got one of these on Heron campus. I believe Riverside has some too. These are very unique leaf shape. This tree species has a male and female individuals. So if you are familiar with Heron campus and that smell that occurs every fall, that is because the female trees have these nasty smelling rotting fruit that fall from them every fall. So if you do like ginkgo trees and want one in your yard, I highly recommend you get a male tree because they won't give you these nasty smelling rotting fruit. Okay, then we've got birch trees. Birch trees are very obvious looking. They have a generally simple looking leaf shape, but they're doubly toothed, so they've got all these teeth along all of their edges. But what's really noticeable about them is the fact that their bark is very peely and paper-like. All right, so then we've got the generic leaf, the bane of my existence, and probably yours if you do these. All right, so if you're seeing an alternate branching pattern with leaves like this or flowers like these in the spring, then it's probably either a Bradford pear or a type of cherry tree or a type of apple tree. All right, the dichotomous key that I've made for you will get you pretty close to what they are, but these are really difficult to tell. Cherry trees are generally elongated with lots and lots of teeth along the edges of them. Okay, apple trees are generally kind of short with lots of teeth around them. And then Bradford pears are also short and very waxy looking. So notice how shiny this guy is up here in comparison to these two down there. But if you're seeing these and you're struggling, a lot of people struggle. And the unfortunate thing is Bradford pears are in a lot of people's yards, and they kind of cause a lot of problems. All right, so last but not leastly, this isn't a tree, all right? But if you're going out and about and exploring the wilds looking for trees, I want you to be able to recognize these plants. First one being poison ivy. Poison ivy leaves comes in threes, and typically, not always, they have a red stem or a little bit of red where their leaves come out. So see where I've already circled here, a little bit of red stem or a little bit of red where the leaves come out. And they always come in threes, and they typically have two mitten-shaped leaves, so a thumb and the rest of the finger, a thumb and the rest of the finger, and then just a normal-ish looking leaf there. All right, so this is poison ivy. You may react to it. You might get little blisters, and if those blisters break and spread those oils to other parts of your skin, it can spread. It's not that great, so try to avoid these. But for some reason, people commonly mistake these for poison ivy as well. This is called Virginia creeper. This is a palmate leaf with groups of fives. It's not a buckeye, looks a lot like it, but this is more of a vine. It's not a tree. It looks similar, but grows in groups of fives, and it's also, again, on the ground as a vine. Can grow up trees, but it's not a tree itself. All right, so I've taken up enough of your time. I really thank you for sticking through with it. I hope this has taught you something, and I hope this makes us seeing you next class a lot more easier when we're walking you through our neighborhoods, showing you trees, and then when you go off and do it for your IP. All right, have a good evening. See you next time.